Okay, welcome to part 1 of exponents. In part 1, if you have already downloaded the wonderful table that has all of the exponent properties, part 1 deals with property number 1. And property number 1 states that when you multiply, you're going to add the exponents or add the powers. So if they have the exact same base or the exact same variable, we can add our exponents when we're multiplying. And so the 3, x cubed times x to the 5th, we add the 3 plus the 5, and it becomes x to the 8th. We're also looking at another form of multiplication, which is parentheses. When you have parentheses with an exponent on the outside, we're going to distribute and multiply that exponent. So all of our exponents would multiply. So in this case, we're distributing that 4th power that's on the outside over to the 2. So 2 to the 4th becomes a 16. And then we also distribute it to the x cubed. And so we're going to multiply those two exponents there. So we have a few example problems that we are going to do in order to make sure that we understand this process. So if I look at part 1, we're actually going to look at number 1. Number 1, I have an x cubed times an x cubed. So I notice I do not have parentheses in this. I'm just multiplying. So when I multiply, I add my exponents. So x to the 3 plus 3 would give me the a to the 6th. Now let's look at a similar problem. Let's look at number 3. Number 3, I have a cubed inside parentheses with a 3 on the outside. Now because I have parentheses to a power, I am going to multiply those two exponents. So in this case it's 3 times 3, and 3 times 3 is going to be 9. So my answer would be a to the 9th. Okay? Let's also look at number 6. Now number 6 is a little bit different. Which kind of problem do you think it is? I have the x squared y cubed inside parentheses with an exponent. So you are correct. Since we have parentheses, it is parentheses to a power, so I'm going to take this wonderful exponent on the outside and we're going to distribute it to both terms on the inside. When we distribute it, we have to do what? Correct, multiply. We are going to multiply that wonderful exponent out there. So now our x is going to have an exponent of 10, and the y has an exponent of 15. So that becomes my new answer. X to the 10th, y to the 15th. Let's look at number 14. Number 14 is kind of tricky. The reason it's tricky is because we look at all those wonderful parentheses in there. And as I look at those parentheses, I notice something. And what I notice is that there are no exponents on the outside. None of these parentheses actually have an exponent there. What that means is that somebody was trying to play a trick on you. And that basically, all this is a big, huge multiply problem. We're just multiplying all 3 terms together. Well, when you multiply, what do you do with your exponents? You add them. But what about those wonderful coefficients out front? The 4 and the negative 3. We're still going to multiply those. So 4 times negative 3 is negative 12. Now I have my r's. I have a 4th power, then I have a 1st power, and then I have another 1st power. Now if I look at my s's, I have a 2nd power, a 3rd power, and then another 1st power. Okay, because remember, if there's no exponent, the power is 1. So my r is to the 6th power, and my s is also to the 6th power. So this is my answer for number 14. Okay, let's look at number 20. Number 20 is a combination problem. We have parentheses with an exponent on the outside, but I've got 2 sets of parentheses with that exponent on the outside. So as I look at this, I notice in the first parenthesis, I'm going to have to distribute that 2 on the outside. That beautiful square is going to get distributed. So the 4 gets squared. The x gets squared. And the y is going to get squared. Okay? Now we need to multiply, because really what's going on between these two parentheses is multiplication. But before we multiply, I have an exponent. I have a power outside parentheses that I have to distribute. Now what is really in front of that x? That's a 1. That's a negative 1. So we have negative 1 cubed with the x cubed and then y. And that's a 2 times the 3, because remember, parentheses to a power, we multiply the powers. So 4 squared is 16. I have an x squared, y squared. That part's easy. Now, negative 1 cubed. Got to think about this. So I have negative 1 times negative 1 times negative 1. So negative 1 times itself 3 times. That gives me a negative 1. Then I have an x cubed, y to the 2 times 3, which makes 6. Okay, now we're down to a multiply problem. So when we multiply, we add the powers. So 16 times a negative 1, well, that's the easy part, because that's just same old, negative 16. Now we're going to add our exponents. So that gives me x to the 5th, y to the 8th. Okay? Now just a little trick to help you guys out with powers to negative 1. Anytime you have negative 1 to an odd power, so if there is an odd numbered exponent here, you're always going to get a negative 1. The even cooler part is if you have negative 1 to an even power, so an even number in the exponent, you'll always get a positive 1 every single time. So you don't have to stop and punch that into the calculator if you have like negative 1 to the 61st power. It's always going to be negative 1 for odd numbers. Let's do one more problem. These are my challenge problems. This is like numbers 26 through 32. Okay, we're actually going to look at number 28. Okay, so I have x to the m minus 2, x to the m plus 2 times an x. Now I notice these beautiful little dots. Those little dots tell me it's a multiply problem. So when we multiply, what do? We add the powers. So I'm going to add each one of those exponents. Now notice I put that beautiful 1 on the end, because we're going to make sure that we're adding each one of our exponents. Beautiful plus signs in between. Now you may be sitting here confused now because we got this big, long, ugly string. Don't forget, you can combine like terms. Okay? So if we're combining like terms, I still have my x, but now let's look. M plus m, well that's 2m, and then I have a minus 2 plus 1. That's a plus 1. And since I cannot combine 2m and plus 1, my answer is x to the 2m plus 1. So that covers part 1 from our notes, and we'll go on to part 2 in a minute.